Hi, this is Jeff Spence, your Math 135 instructor for the Community College of Denver, and this is our lecture over 3.2. 3.2 is titled Measures of Variability. Another way to say it is a measure of spread of a data set. So remember in 3.1 we were looking at measures of center, mainly the mean and the median are good measures. Now we're going to look and focus on measures of spread such as the range and the standard deviation. We'll also have the variance as a calculation, but the good measures of spread that we're going to look at are range and standard deviation. So we introduced the range first, but the first point that the book wants to make with these visuals and these data values is that these two women's volleyball teams, Western Mass and Northern Connecticut, have exactly the same mean, median, and mode. You can see the same red triangle as the mean, the median, and the mode are all the same at 70. So they're exactly the same for the two data sets. But notice the Western Massachusetts University heights have a much larger spread because they have a height at 60 and a height at 75, while the range and spread of the Northern Connecticut team is much smaller. So while some data sets may have the exact same mean, the exact same median, and the exact same mode, doesn't mean the data sets are equal. So we start off with calculating the range. The range is pretty simple. It's a simple subtraction. You always take the largest value and you subtract the smallest value. So you can see the range for the Western Massachusetts team is 15, while the range for the Northern Connecticut team is only 6. So that's showing that these data sets, one is much more spread out than the other. 15 is much more spread out than 6. Next, a much more complicated measure of spread is the standard deviation. So we need to start with just this word, what a deviation is. So first, the range is really easy to calculate, but it has drawbacks. Like there could be some outliers. What if you have an outlier on the right-hand side? It can stretch the range out when all the rest of the data values are really close. So the range might not be that accurate. Sometimes it is, sometimes it isn't. So we have another measure, the standard deviation. So first, what's a deviation? A deviation is for any given data value. So every data value has a deviation. The deviation is essentially the distance from that data value to the mean. So for any data value, you subtract the mean. They're showing you two formulas here: x minus x bar or x minus mu, depending on if you know the population mean or the sample mean. But remember, they're essentially the same thing. So any deviation is just the distance from the mean. 3 important points here. If the data value is larger than the mean, then the deviation should be positive. That makes sense? If the data value is smaller than the mean, then the deviation will be negative. And if the data value equals the mean, then the deviation should be 0 because they're the same value. So the main thing is that when we take all the deviations of all the data values, so every data value has a deviation. If you add up all the deviations, some will be positive, some will be negative, some might be 0. But there's a rule that if you add up all the deviations, they will always equal 0. So this is where we come up with this thing called the variance. Since the sum of the deviations is always 0, instead of just taking each deviation, x minus mu here, we square the deviations so that the negative ones don't cancel with the positive ones. We sum up all the squared deviations, that's the numerator in this formula, and essentially find the average of the sum of the squared deviation. That's why we divide by however many things we have. So this is the formula for the population variance. So we square the deviations, add them all up, and divide by however many data values we have. That gives you the population variance. Lastly, the last step to get the standard deviation, since we squared all the deviations, is we have to square root everything back. So after you do all the adding up and dividing by n, you square root it back and you get the population standard deviation. The sample standard deviation is essentially the same and the variance is essentially the same, but instead of dividing by the number of items that we have, we divide by the number of items that we have minus 1. This is the one that we're going to actually use more often, the sample standard deviation, because more often than not we're conducting samples. In the next video, I'm going to show you an example of how we can use either one of these formulas.